Hello and welcome to Euphoria. In this series of videos I'll be explaining how I developed the concept, design and build for a LEGO creation of my own design, a MOC. I'm designing a building for my LEGO city. It will be a modern multi-storey office building that will be used as a research institute. In previous videos we looked at the inspiration behind this MOC, the development of the concept for the building and the selection of options leading to an outline design. If you haven't seen them yet, you might want to look at the previous videos in this series, particularly the one looking at the outline design. There's a link in the card above and in the description below. So here's a reminder of the outline design for this MOC that I developed in the previous video in this series. To develop my ideas, I bought and built the LEGO Avengers Tower from set 76166. There are some useful parts and interesting ideas in that set, including lots of large windows and some curved panels. So I want my MOC to use those parts and a similar colour palette to that set. The design has already departed considerably from that original set. It's going to be a straight modular building, which means it needs to follow the modular building standards and be able to connect to a modular building at each side. I want to try to develop a design that can be built on either a 32 wide footprint or a 48 wide footprint. It will be 4 or 5 stories high and have a profile which includes sloping windows at the front and may have curves at the sides or at the back. Here's an idea in a smaller scale of what the shape of the building could be. Now, this building will be used as a research institute, so I want to use some of the minifigures and accessories from the Space Research and Development People Pack to populate the building. So although that's a reasonable rough outline design, I have quite a lot of structural design work to do to figure out how I can make that into a sound design for a modular building that I could actually build. So in this phase of design I'm going to look at the structural design, which will cover the design of the walls, the floors and the roof that form the main structure of the building. Based on the previous work, we will develop the basic shape of the MOC, work out the size of the MOC, that is, its overall dimensions, work out whether the building is made out of separate sections that can be constructed separately. For a modular MOC, this will at least be the separate floors of the building, and these decisions should let me develop the rough floor plans for the different stories or levels of the building. I'll also need to consider how the design provides support for the floors and the roof, whether it has enough strength, and how it will conform to the modular building standards. All of those factors go into producing the structural design. That's why I call this the S phase of the design process. I'll be developing this design in a combination of computer-aided design using Bricklink Studio, and there will be an element of prototyping using real bricks. This will run alongside the design phases so that I can check how some of the elements fit together physically, to test the strength of some assemblies and to see how things look. For this particular MOC, I've already got an idea of the colour scheme that I want to use because I built the Avengers Tower from set 76166. That gave me some ideas for the build and some useful parts, but although that was the starting point, I'm not too wedded to the actual structures and build techniques in that set, and I'll do what I think this design really needs. If you want to see how I built that set, there's a video on my channel. There's a link in the card above and in the description below. So in this video I need to cover some high-level design decisions such as the floor plan for the building, wall heights and outlines, leading to what would be called in architectural terms the elevations of the building on different sides, the separate sections that will be constructed as the 5 separate stories of the building, how to include the elevator in the design of the roof, that's the shape and how it will be constructed, how the floors and roof will be supported, wall thicknesses and openings or gaps in the walls, and how to meet the modular standards, that's the position of the modular connections and any blank or connecting walls and the pavement. So now let's make a start on the structural design for this MOC. First I'm going to look at the size and shape of the building. That should give me the footprint of the building and the position of the main features, and from there I can develop the floor plans. Although the Avengers Tower set looked nice and opened up to access the interior, it wasn't wide enough or deep enough to be regarded as a modular building. So I need to work up a design that's the right size. That means it has to be 32 studs wide and between 16 and 20 studs deep. But I also want to have a design that could be expanded to be 48 studs wide, which would make a much more impressive building, but wouldn't cost hugely more than a 32 stud wide building. So the footprint of the building would look something like this. Now, one of the main ideas behind this building is to create sloping window panels to provide some interest to the shape of the building and prevent it just being a plain square block. So I've been working out ways to make the sloping window panels that I'll need. I didn't really like the way the Avengers Tower did it. It was very clever and had some window panels that folded open from the top and others that folded open from the bottom. But if I'm making this into a modular building, I don't really need to do that. So I've prototyped sloping window panels using these rocker or hinge pieces. They can be swung inwards like this, or if they're turned around then they can be swung outwards like this. When it comes to the width of the building, as I explained in the outline design, I want to consider the options of making both a 32 stud wide version and a 48 stud wide version. I want to consider both versions before deciding on one to build. The 32 stud version would be cheaper, but I think the 48 stud version would be more impressive. There will be a number of vertical supports in between window panels that go right across the front and back of the building. The window panels will be made from window frames that are 4 studs wide. If I make a 32 stud wide version, then the window panels could be 8 studs wide, 12 studs wide and 8 studs wide like this. If I make the 48 stud wide version, then the window panels could be 16, 12 and 16 studs wide like this. The height of the panels can be any height I need if I use combinations of window frames, or I can make window panels out of transparent bricks which come in different sizes or even in the larger panel pieces. But I don't want to make very tall walls all in one piece, so I need to consider how I'm going to make the building in floors that can be separated to get access to the interior. The stories in a modular building need to be about 8, 9 or 10 bricks high to be a sensible minifigure scale and to look right alongside other modular buildings. That does make it a bit difficult if I'm trying to make smooth sloping walls, because the slopes will be interrupted by the floors. I have thought about lots of ideas, such as having sloping walls that are not connected to the interior floors, having walls that are more than 1 story high, or having mezzanine floors built inside an external shell for the building. But I decided that these would be difficult to build and difficult to access the interiors, and would probably not be very structurally sound. You may recall that as part of the design I want to have an elevator or lift instead of lots of flights of stairs. So I need to work out how I can make an elevator that works within the framework of a modular building. An elevator usually has an elevator shaft that goes up through all the floors of the building and sometimes up to the roof. But it could take quite a lot of bricks and use up quite a lot of room to have an enclosed elevator shaft on all the floors. But some modern buildings do away with the need for an elevator shaft by having an external elevator, and I wondered if I could do the same. I tried lots of ideas for an elevator shaft or an external elevator. I might do a separate video about how I settled on the design for the elevator, but after some experimentation I came up with the idea of using roller coaster tracks as the tracks for an external elevator by using them vertically instead of horizontally. There is quite a variety of roller coaster track elements available, but there are only 2 straight track sections. There's a short one, which is 8 studs long, and a long one, which is 16 studs long. If I mount them vertically, then the short one becomes 6 2/3 bricks high, and the long one becomes 13 1/3 bricks high. To make the floors of the building separable, then ideally the track breaks will be at the same point as the breaks between stories in the building. But if I just use the shorter track piece for each story, then each level of the building would be only 6 2/3 bricks high. That isn't really tall enough, and certainly not appropriate for a modern office building. On the other hand, if I used a long track piece, then each level of the building would be 13 1/3 bricks high. Building with stories that are 13 1/3 bricks high does give a spacious feel to the building. It also provides the height to make the window panels work. I can make window panels to fit the floor heights using window frames. I can use 2 rows of 4 by 6 window frames to make a window panel that's 12 bricks high. That leaves enough space for the floor plates and the tiling layer between floors. I tend to use green tiles for the tiling layer between floors during the design phase, although they won't be that colour in the final design. For the sloping windows, I can use the hinge bricks that I showed earlier, combined with window frames in different sizes to make panels that fit within the floor height. I'll just quickly look at the roof for this building. Sometimes the roof is the most difficult part of a MOC to design, especially if it's a complicated shape. Even when building it in LEGO, you have to think about whether the roof will be strong enough. And if you're going to make the roof so that it can be removed, so that you can get inside the building, then you have to think about how the roof section itself will be built and whether it will be strong enough. For this MOC, I just intend to build a flat roof. I can build that out of plates like the other floor plates. At the top, I can finish off the top of the building with a parapet, and there'll be a machinery room on the roof to provide the mechanism for the elevator. But otherwise, I don't foresee the roof on this MOC to be particularly difficult to design structurally, providing I can support it in the same way as the floors. In the outline design, I said that I wanted to use curved panels, but I couldn't see how to fit them into the building. They don't really combine very well with slopes. But I do like the curved trans-light blue panels that came with the Avengers Tower building. So I've decided to incorporate the curved panels into the back of this MOC. I will need to keep the same girder and panel structure at the back as I have at the front, but I can still use the curved panels to inset the elevator within the footprint of the base plate. The roller coaster tracks and the elevator can fit quite well in the central panel, which is 12 studs wide. One of the main factors in this design is that I want it to meet the standards and conventions for modular buildings. Without those constraints, I could make this building any size or shape that I wanted. But I have to make the building so that other buildings could go on the sides. That means that the building has to incorporate the connection points for modular buildings at the sides and have a pavement or sidewalk at the front, as shown here. That gives me a depth for the building of about 16 studs. If possible, I'd like to use large panels to make the sides of the building to keep costs down. But I have to remember that if the building is placed next to other buildings, then the first couple of stories are likely to be next to the adjoining buildings, and so need to have solid walls rather than windows. Now I want to look at how I'm going to support the floors and roof and provide the structural integrity for the building. The building will be supported by the side walls and by vertical columns of bricks between the window panels. Where I want to achieve the sloping effect, then I can use the slope bricks and matching inverse slope bricks to make a sloping frame structure. The window panels fit between the vertical columns, and where they are sloping, then I can adjust the angle to match that of the sloping columns. The floor plates will be made from 2 layers of plates. Larger plates to make the actual floor, and longer plates, which are generally 2 studs wide, to bind them together and provide strength. In this design, I've made the whole 48 wide floor in one piece. You may think that's too large and fragile, but when I've done it before in a 48 wide MOC, it seems to be pretty strong, even when it has holes in it, such as this example from my extended brick bank modular building. So the floors will be pretty strong, but they will need some support underneath. And I also need to find a way of tying the walls together. This is going to be mostly an open plan building, so there won't be many internal walls to support the floors above. So what I've done is put some beams across the top of each floor to bind the walls together and support the floors above. So now we've got the structural design for this MOC. It's looking like a building that could be constructed out of LEGO, and we have a clear idea of what it will look like. This is the design. It's pretty close to the original shape that I selected during the options analysis and outline design, with the sloping panels progressing up and across the facade of the building. The elevator tracks run up the back of the building, and I've also managed to incorporate the use of curved panels at the back of the building. In this structural design phase, we've developed the basic shape of the MOC, we've worked out its size, we've worked out the separate sections that will be constructed as the 5 separate stories of the building. We've also considered how the design provides support for the floors and the roof, whether it has enough strength, and how it will conform to the modular building standards. Before I move on to the detailed design, I really want to check out whether the elevator is going to work with the vertical roller coaster tracks. If it doesn't work, then I'm going to have to modify the structure to include a different form of elevator shaft. So I'll be making a prototype of the elevator to see if it really works. There are still quite a few things to decide as we develop the detailed design for this MOC. So look out for the next video in this series, in which I will look at the next stage of the design for this MOC. Thanks for watching. Please let me know what you think in the comments below, and subscribe to this channel if you want to see more videos about LEGO modular building.